what I want to do in this video is go over what I think is one of the more intuitive ways to sort a list. It's how I would probably sort it if I had to do it manually. But I want to make it clear, it is not the most efficient way to sort a list. But let's just, I think it's a good starting point when we getting warmed up with sorting lists. It's called insertion sort. Insertion sort. And I'm going to give a graphical description of the algorithm for insertion sort. And just so you know what algorithm sounds like a very fancy word, but an algorithm is really just a way of sorting it, or a process for doing it, or a method for doing it. A program is a specific implementation of an algorithm, or it can be a specific implementation of an algorithm. Once I have a general algorithm, I could implement it in Python, I could implement it in C, I could implement it in Java. Those are specific programs, but they'd all be implementing the same way of doing the sort. And that's what I'm describing here, the insertion sort algorithm. So let's just start with a simple example. Let's say that I have a list. Let's say I have a Python list, because we're going to be working in Python for this. And that list is, let's say it is 7, 3, 1, 2, 4, 6. And so the way that we do insertion sort is you go element by element, and then you compare it to the elements before it, and that you look for the first element before it that it is actually less than, and then you just stick it right over there. So let me show you what I'm talking about. So you could start with the 7, the 0th element over here, but when you start with the 0th element, you're like, hey, wait, there's nothing before it to compare it to. So it really doesn't make sense to start with the 0th element. So really, if you were to implement this algorithm, you'll start it with the 3rd element. Or sorry, you'll start it with this. If this is the 0th element, you'd start it with the 1st element right over here. This is 0th, this is 1st. I know this can be a little confusing when you refer to this as the 1st element, but this one's the 0th. So you start with this 3 here, and then you start comparing it to all of the elements before it. And as soon as you find an element that 3 is less than, you stick it in that part of the list. So what you do is you say, OK, is 3 less than 7? Well, yeah, it is less than 7. So what you want to do is you want to shift 7 where the 3 is. So let me put it out here. So we're trying to compare 3 to everything before it right now. We're trying to compare 3 to everything before it. So you say, OK, is 3 less than 7? Yeah, it is less than 7. So let's put the 7 where the 3 is. So let's put the 7 where the 3 is. And let's put the 3 where the 7 is. And let's put the 3 where the 7 is, especially because there's nothing left to compare the 3 to. There's nothing lower. There's no elements before the 0th element. So let's just stick the 3 right over there. And so our list now looks like this. Our list now looks like 3, 7, 1, 2, 4, and 6. And one thing you'll find interesting, or something to pay attention to, is as we build this list, so the 0th element is now definitely less than the 1st element, and everything up to and including the 1st element is now sorted. Everything up to and including the 1st element is now sorted. And that will be true as we keep going through this, as we keep going through higher and higher indexes. Up to and including that index, after we've done that pass, will be sorted. And I'll try to point that out as we go along. So we did the 1st index. So we already did the 1st index. Now we can move on to the 2nd element, which is this 1 over here. And so you take that 1. I'll put it on the side right over here. You take that 1 and you compare it to each of the elements before it. OK, is 1 less than 7? Sure, 1 is less than 7. So let's stick the 7 where the 1 is. Let's stick the 7 where the 1 is. And then you could either you could just keep comparing, or you could just stick the 1 where the 7 is. And then you would say, OK, is 1 less than 3? Well, yeah, sure, it's less than 3. So let's stick the 3 where the 1 is. And let's put the 1 where the 3 is. And let's put the 1 where the 3 is. So what is our list now? Our list now is going to look like, our list now is going to be 1, 1, 3, 7, 2, 4, 6. So notice, after we've gotten to the nth index, so in this case, this was the index of 2, where that 1 was right over there, everything up to and including that index is sorted. This part right here is sorted. It's going to be, other things are going to be thrown in here probably as we go on, but so far this part is sorted. So you can see by the time we get to the end of this list, everything is going to be sorted. So let's now go to the next index, or the next item in the list. And that is this 2 over here. That is the 2 over here. And so we compare the 2 to the 7. 2 is definitely less than the 7. So let's put the 7 where the 2 is, and let's put the 2 where the 7 is. Now you compare the 2 to the 3. 2 is less than 3. So let's put the 3 where the 2 is, and let's put the 2 where the 3 is. Then compare 2 to 1. Is 2 less than 1? No, it is not less than 1. So we don't have to do anything else. We don't have to keep going to the left. And so now after this pass, and this pass we were comparing this 2 item to everything before that. So after this pass, our list looks like this. Our list looks like 1, 2, 3, 1, 2, 3, 7, 4, 6. And notice everything up to and including the third item, so 0th, 1, 2, third item, is now sorted. And now we're ready to look at the next element in the list. And one thing I want to make clear, when you actually implement it, there's a couple of ways to do it. You don't always have to. So in this example, we said, hey, 2 is less than 7. We had the 7 replace where the 2 is, which you should do. And then we had the 2 replace where the 7 is. But the reality is, you can keep going down until you find a good place to put the 2, and shifting everything to the right as you do it, and then putting the 2 in. Although this way, it's a little bit easier to keep track of. And well, maybe we'll explore different ways to do it when we actually implement the algorithm. Anyway, let's look at this 4. Same exact idea. 4 is less than 7, so let's put the 7 where the 4 is and put the 4 where the 7 is. Is 4 less than 3? No, it's not less than 3, so we stop. We're done. Now everything up to and including the 4th item in this list, 0, 1, 2, 3, 4, is now sorted. And now our list looks like, let me scroll down a little bit. Now our list looks like this. Let me write it down. It is 1, 2, 3, 1, 2, 3, 4, 7, and then 6. And now we can go to this last element in the list. The last element in the list, this is the 6 that we're now comparing. Actually, in the last time we did this, it was a 4 that we cared about. But now we care about the 6. Is 6 less than 7? Sure it is. So let's put 7 where the 6 is. Let's put a 6 where the 7 is. Is 6 less than 4? No, it's not. And so we stop, because we know that this is going to be sorted. If we went any further, we're just going to get elements that are less than or equal to 4. So we are done. We have sorted this list. The sorted list is now 1, 2, 3, 4, 6, and 7. In the next video, I'm actually going to try to implement this algorithm that I just described. And I'm going to implement it in a simple Python function.